G'day folks, it's me again. It's been a while since I last uploaded a video and I thought I might as well do one. Today's little video we're going to have a look at this Variac plinth which I put together quite a while ago. I thought might as well show it off. I've had that Variac for years and it's quite heavy and unwieldy, and when I wanted to use it I was fed up of pulling it out, setting it all up, hooking up all the cables and everything. So I thought I might as well put it on like a portable station where I've got outlets, meters and everything. I can just push round, push out the way when I'm finished, and it'll all be self-contained. So let's have a closer look, shall we? So on top of the unit we've got the business end. That's the Variac itself. It's a Carroll and Maynell Variac. I can't remember the exact number, but it's rated at 15 amps with an output of 0 to 270 volts. It's a pretty decent Variac. I've had over 20 amps through it and it didn't seem to complain, but that was for short periods of time. Probably wouldn't want to overload it too much for too long. Anyway, it can do it for short periods. It's pretty ballsy. And going further down, so we've got the main control unit. On the left is the main power switch which controls everything. In the middle we've got the power meter which shows us the total power, the voltage and the current of the output. On the right hand side we've got the switch that controls the main output and its associated warning light. Going further down, on the right we've got a standard UK BS 1363 outlet. In the middle is a 20 amp C19 and on the left is a 10 amp C13. Let's have a look inside, shall we? So this is inside. Doing all the work is a couple of great big nice chunky contactors. The one on the left is the one feeding the Variac. The one on the right is the outputs. On the far left is a timer which I'll go into further detail in a minute. That controls the soft start unit. The 1 amp circuit breaker is protecting the meters and switches and everything else. The 16 amp breaker on the right is on the main outputs. So down below in the cabinet is the current transformer for the meter and the soft start unit. Now this Variac, and well most big Variacs, have a problem with inrush current. If I was to power this on, it would be a 50-50 chance it would take out a B32 breaker which is feeding it, which is quite annoying. And if this has been off for a while, then guaranteed it would pop the breaker like instantly, because they do have quite large inrush currents. And the way I've got round to it is that 15 watt pygmy lamp is in series with the Variac. So when you first power it on, the power goes through that, the lamp limits the current, and then after a couple of seconds that contactor on the left closes and shorts the lamp out of the circuit, which is it's quite a good soft start unit. It works. A bit overcomplicated. You could have done the same thing with an MOV or something, but I might as well gild the lily and make it super complicated just because, well, I was bored and I can. Just a wide shot showing the front panel or the door. We've got the main meter, the switches and the warning lights along with the output. All the control side is wired in 1mm tri-rated cable, which is pretty decent stuff, high temp rated and everything. All the main power output is 2.5mm tri-rated, and I think that's actually rated for 30 amps, so I've got, well, it's never going to see 30 amps. Well, it's decent anyway. Bit messy, but as I say, I didn't really have any plan when I wired it up. I just did it as I went along. Yeah, big lamp propping the door open as well there. Might see that in a future video. Oh well, let's power it up and see how it goes. Just as a quick test, we've got a 2000 watt double jacketed tungsten halogen lamp on the output, which is going to chuck out loads of heat when we start to wind it up. So to power it on, you just flip the main switch, meter comes on. After a couple of seconds, after the soft start unit has done its thing, it's ready. We've got the main switch to control the output. I've actually wired this lamp through the contactor, so even if the coil is de-energized, if that contactor is stuck in for whatever reason, that light will always be on. So anyway, we're on now. We can start winding the wick up. Now I'm going to feel this. I can feel it already. That's oh yeah, there's some infrared coming off that lamp. Yeah, 120 volts, 6 amps. There's 1000 watts coming up. Oof, I can feel that. Jesus. Yeah, that's pretty goddamn warm. So 1600 watts, 17, 18. Now we're at 2000 watts now, as the lamp is rated 2 kilowatt. But we're at 230 volts. This lamp says it's 240 volt rated, but obviously, as we can see, this is actually a 230 volt lamp. If I go up to 240, then we're almost 150 watts over its rated power. Obviously I can go a bit more and be a bit silly, but oh, that's hot, that is. Bloody hell. I won't go too much anyway. Let's go back down to 2 kilowatt. You can get really fine control, which is good for obviously annulling mains voltage fluctuations. Can I get exactly 2 kilowatt? Bit more. Come on. Need to stick your tongue out at the right angle. 230. Oh there, yeah, look at that. Oh, I had it then for a minute. And obviously when we're finished, I'm going to turn it off now because my face is starting to melt. Main switch. Wind it back to 0. Power off. Anyway, thanks for watching. I hope you've enjoyed it. Any comments, any criticism, which probably is going to be a lot, feel free to leave it down in the box, and hopefully I'll have some more videos coming up soon. Probably, I say that, it's probably going to be about 2 years. Anyway, thanks for watching. Bye bye now.